Well, hello everyone. For today's video, we're gonna be moving the last piece of code that we had in 5.3 to 5.4, and that involves. It's actually going to be pretty quick, just like before. It's going to be some just a little bit of copy and pasting and a lot of the code you've seen in the last stream. This is about casting the ray to see what objects or are in front of you. So here's a quick preview of what that is. And like I said, it should be very simple. So let's open this up here. So I have two objects here. One of them is actually, just bring this over so I can show you. This is a brush. So we don't really care about those. You don't want to read the class of every single rock out there or anything like that. And then we have this one, which this one is, and this one's an entity. So once we jump into game, you'll notice that and we'll remove that thing on top of the head, which was to casting the ray to see if we can stand or not. But if you look in front of you, you'll see that there's that little yellow sphere, and that's what our ray casting will do. So you'll see that it collides with the object, but in this case, we're not getting the class of it. But if we go to this one, you'll notice that, okay, we get a persistent debug in this case, and that this one's an entity. So that's what we care about. As we move along with this these series, we'll create some custom entities as well, and those are going to be a little special. So you'll know that that piece is something like, like a health potion or maybe a weapon. So we'll know what to do if we pick it up, or or any other actions are performed on it. Okay, so let's jump into code. This was just my test level. So let's take a look. This is our stream project here. So let's reveal this in Explorer and go to our solution. So there we go, right here. Okay, so solution is open. We have some of the work that we've done for animation. That's not what we're looking for today, but our code is going to go in this update camera because this is where we're looking at, so that's where we're interested in. So in order to move the code over, what we did in 5.3 was actually create a function that was just named Raycast. So I'm just going to copy that over and we'll go over it real quick, just as a reminder. Okay, so let's see, where do we want to place it? We'll probably place it somewhere around here because we have these. I'm just going to make a quick comment. Raycasting. Okay, so you'll see that our raycast is going to need an origin, a direction, and what to skip. In our case, is going to be our player because we don't want to collide with our player again. So let's quickly go in and create definition. And here we have it. I'm just going to save this and close it. It's kind of small. So let's look for raycast. One thing that you can do is actually in this drop down here, you can look for raycast like that, which is pretty slick. Okay, so in here, I'm going to go ahead and copy some of this code, and we'll go over it. So first of all, there's going to be a few variables, and one of them is going to be, we have our raycast. So, and we call this hit. Yeah, that should be it. There we go. Just IntelliSense catching up with the coloring scheme. And then we have a float, and this float is going to be, I'm going to call this interaction distance, and this is going to be 10.0f. So this is going to be our how far our ray is going to go. So do we want to interact with objects that are 10 meters in front of us, or 100 meters in front of us? That's entirely up to you. Okay, so we have that, the distance. Now let's do our direction. So our direction is going to be made off of our quaternion direction and our interaction distance. So how far do we want to shoot the ray? So it's going to be vec3 of this is going to be final null direction, and this is going to be equal to our quaternion dir times of vec3 composed of, and this is going to be how do we want to shoot the ray, right? So we want to shoot it right in front of us. We don't want to shoot it to the left or to the right or behind us, right? So that's going to be 0.0 on the x, then an interaction distance on the y, and did I spell that right? There we go, it's right there. Interaction distance, and then 0.0f on the z. Oh man, if I can type, that'd be terrific. Okay, so now we have that final direction, and what objects are we going to look for? So this flag is going to be an int object types, and we're going to use that entity all. There we go. All right, so then we have another type of flag. I'm trying to make sense of these and how do they kind of work together, and but it's needed by the raycast. So it's going to be a const unsigned int unsigned int, and we'll call this flags. And in here, what do we want to stop at? So we want to stop at, and this is going to be stop at pierceable, RWI, and collision type any. Alright, so there's that. And now we want to also add the entities that we want to skip over. So that's going to be our player. So this is going to be a static. And if you remember, we used this previously in that shoot ray from head, where we were determining the distance between the player and whatever's on top of him. So it's going to be a static physical entity, and it's a pointer to an array of p skip entities, and we'll make that of 10. Maybe we want to add something onto that later on. Okay, so entities, and 0 is going to be our entity that we pass along. So key skip entity dot get physics. So get physics, there we go. Okay, so now it's time to cast array. So through the global environment variable, and then we reach into the physical world and array world intersection. So let's pass in some of these parameters that we have. So first, we want to start at the origin, and then we want to cast it along the final direction. Then we have a flag for these object types. Then our flags then our actual casting, I believe this is what it is, or where it actually hits. So, and this is going to be hit. Then one, I could never, I mean, I'm thinking it's just the maximum number of hits, so we just want the first hit, and then our skip entities. Skip entities, all right. And two, like I said, I was never able to understand what that is. It seems to be needed. I'm sorry, I wish I could tell you more. Okay, so now a quick thing that we're going to add is just a persistent debug to see, just to cast, create a sphere where we're colliding with something. And actually, I mean, we want to have that, at least for testing in the beginning. So system debug, and what was before, we call this p persistent debug. And again, we're just going into the global environment variable and reaching out into the P game framework, and we're going to get the persistent debug. So I persistent debug, just like we've done it quite a few times. Okay, so now let's see if we hit something. So if we have a hit.p collider, so let's begin our raycast, right? So ppd, and this is, I've never really understood what begin is for, but it seems to be part of the whole persistent debug world, I guess. And ppd, and we're going to add a sphere. So add sphere, and where do we want to place this? So it's going to be a hit.point for the vector. Then a radius of it is going to be, I've put it at 0.25f. So and then a color, so color f, and this is going to be a vec3, and we can make this, I think I've made it kind of a yellow, so 1, 1, 0, and then a this constant, the float is, I believe, the alpha. So this is going to be 0.5f. Oh, actually, I think that was it. Oh, hey, Oscar. Thanks for stopping by. And then the last parameter is going to be the length of the timeout of the sphere. Okay, so now that we're casting the sphere, and actually I think I should have checked to see if the pointer got initialized, just so. Alright, there you go. So there's that. Okay, so now let's actually see what we collided with, right? So I'm going to do a physical entity, and this is going to be a p hit, p hit entity. Alright, and this is going to be our hit dot p collider. Alright, so now let's see about what entity it is. So I to t equals, so through the global environment variable, and this is going to be in the p entity system, and we're going to get entity from physics. And what physics, you might ask? Our p hit entity that we just declared. Alright, so now if indeed there's something there, what do we want to do? We want to get the class name of it, right? So let's create a entity class. It's going to be a pointer, and we're going to name it P class, kind of keep it simple. And that equals to our P entity that we just have here. And get the class of that. And get class. There we go. Alright, so one thing that we need to declare is this P class name. And I believe, let me see, I think I should have added that onto it. So let's just add that as a quick variable here. So that's going to be a const character, and this is P class name. And we're going to set that to just an empty string for now. And here, once we get the class of it, let's get its name. So P class name equals P class arrow get name. Alright, so we have the name of it. Now we just probably want to display it, right? So if P persistent debug, then let's just add some text about that. So P persistent debug, and for this one I'm just going to use add 3D text, or text 3D I guess is what the order of it, and I want to place the text right on top of where we collided with, or the ray collided with something. So it's going to be hit.point the size of it, then again the color, so I'm just going to copy the color from here because it's basically almost identical. And then the last parameter is the P class name. There we go. Okay, so our raycast is complete. Let's actually call that. And we said that we want to call it in, let's see, where are we? So we want to call it right here in the update camera. So I believe if we place it right above this one, we should be good to go, right above this local transform. So raycast, and what do we want to pass along? So the origin, so the starting of our the cast. So this is going to be from where the camera is. So if you remember from last time, we had this collision, camera collision work that we've done. In the end, the view offset was based on our destination. So we're going to start off at destination, and the direction of it is actually going to be, let's see, where is it? It's going to be this M look orientation, which is already provided through the template. So M underscore look orientation, and then the thing that we want to we don't want to collide with, right? It's going to be our player, and we already have that here. So player entity. So I'm just going to copy this here and pass it right there. Okay, so with that said, let's go ahead and build this and see what we get in Engine. Alright, so that's built successfully. Let's go to our stream example project here. Alright, so let's open up our test level. And right now, let's jump into game mode. And as you can see, we're casting that little yellowish, orangish, kind of bad with colors sometimes, sphere, and it's colliding with things. But we're not really, we're not getting anything out of it. Well, mostly because these are all brushes. So let's add a static mesh entity, which I believe in the old engine there used to be game objects maybe. So let's add in a primitive pyramid. So these are all going to be entities. Alright, so there we go. So we know that thing is an entity. And let's see, I'm not sure if we can, if we add one like a weapon, I believe this is also going to be seen as an entity. I'm not entirely sure. Or maybe not at all, because it doesn't have, I think it doesn't have collisions. So yeah, so it doesn't, these ones don't have collisions. And I believe, I mean, they need to have collisions for our ray to hit something. So you can see that the player is excluded out of our collisions, so we don't care about that. So there we go. That is pretty much it for, we have an entity right there. That is pretty much it for what I wanted to show today. And for next stream, hopefully next week, I'm planning to do a stream on creating your own console variables. That should be also a pretty quick stream, pretty simple. And the case that we're going to use that for might actually be for this, where do we do the raycast? So raycast, there we go. So hey, Death Trooper, yeah, hey, thanks so much for enjoying the stream. Hopefully you got something out of it. Like I said, for the next stream, we're going to do some console variables, and I'm thinking the first one that we're going to do is actually this interaction distance. So oh yeah, and Oscar Ocho Unos, he's also done console commands tutorial some he says long time ago. So hopefully some of that will apply, and I'll be able to get to use some of that as well. So I'm thinking the use case for our needs is going to be this interaction distance. So you'll be able to just type into the console maybe G underscore interaction distance and change that to 100, so you'd be able to cast that ray at 100 meters instead of 10. That would be a use case, maybe not practical for the game, to allow the player to set that to a bigger distance that you're intending. You don't want to interact with everything in the level at that kind of a distance. So thank you guys so much for stopping by, and until next week, I hope you guys have a great week coming up, and yeah, thanks again for stopping by. Bye.